Okay, good afternoon, everyone. I hope you can hear me and see my screen also. Okay, so if you cannot, please send a text message. Okay, so if you can see the screen, okay, and then yeah, try that question. Yeah, good afternoon, everyone. Good afternoon, Lohit. Yeah, thanks. Okay, so we'll start with the first question. Yes, okay, I'm displaying you the question. Try this question now. So yeah, still there are three more algorithms to discuss. We'll discuss one question, one algorithm, so that you'll not get this bored. Okay. So we'll complete this question and then we'll discuss one algorithm. Okay. So after then we'll discuss some questions and then okay, some algorithms. Yeah. Try this question. Yes. And one more thing. From tomorrow, everyone join before 2:30 because exactly by 2:30 I'll be starting the session. Okay. Uh, Fine. Yes. Read the question. Read the question and try to understand. Yeah. What is given? Okay. Let me read the question for you. Some prime numbers can be expressed as a sum of other consecutive prime numbers. For example, 5 is equal to 2 plus 3. 17 is equal to 2 plus 3 plus 5 plus 7. Yes. Okay. And 41 is equal to 2 plus 3 plus 5 plus 7 plus 7 plus 13. Okay. Okay. Now the task is to find out how many prime numbers. Okay. How many prime numbers which satisfy this property are present in the range from 3 to n. Okay. Subject to a constraint that summation should always start with number 2. Okay. Input format, they gave some input format. Okay. So first line contains a number n, and output format should be what? The output format should be print the total number of all such prime numbers which are less than or equal to n. Okay. They gave these constraints. Yeah. Number can be number should be less than this bigger number. Okay. And they gave some sample input. For example, if sample input is 20. Okay. So if sample input is 20, uh, then output should be 2. Okay. So because there are only two numbers uh, which are satisfying this condition. Okay. If it is 15, uh, there should be only one number because only 5. Yes. Uh, this is the question. Okay. Uh, so try to find out. Can anyone tell me what is the logic? The question is very easy. Yes. Question is very easy. Just prime number logic. Okay. So tell me what to do. Any ideas here? Any ideas to solve this question? Yeah. How can I solve this question? Any logics? Question is very easy. It is not difficult. Okay. So secondary easy level question. Yeah. Fine. So I hope need not explain this question also. I hope everyone can understand it. Yes. Yeah. Uh, Fine. Let me see this. Let us see this question. Okay. What is given? Some prime numbers can be expressed. Some prime numbers can be expressed as sum of other consecutive prime numbers. Yes. Okay. So yeah, they'll be giving you n value. They'll be giving us n value. Okay. So in that n value, I need to find how many numbers can be expressed as sum of prime numbers. Okay. So let me take some input. Okay. Yeah, I'm taking the second input, which is 15. Okay. So if I take 15 as n value, okay, my numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let it be. Okay, we'll take 20, 16, 17, 18, 19, and 20. Okay. So let us take n value as 20. Okay. So in this first, can anyone tell me how many? What are the prime numbers? They are not asking count of prime numbers. Yes. So if they're asking count of prime numbers, just what we can do. So find out the prime numbers. Whenever you get a number, increment the count and then print that count. Okay. So here they are asking how many numbers can be expressed as a sum of prime numbers. Yes. Okay. Yeah, and that too, some prime numbers can be expressed. So if you observe, some prime numbers can be expressed as a sum of other consecutive prime numbers. It is not general number. Okay, for example, if I take okay, so if I take any number 8, okay, so 8 can be represented as 3 plus 5. Okay, so whenever a number is 8, I cannot take 8 under this condition. Okay, so if you observe, there should be a prime number which can be expressed as a sum of prime numbers. So here 8 is not a prime number, so I cannot consider that number. Okay, so remember, it should be only a prime number. Okay, so prime numbers should be prime numbers. Okay, should be expressed as a sum of other prime numbers. Yes. Okay, so yeah, only the prime numbers. Okay, so it is not normal numbers, so it should be a prime number, and that should be able to express as a sum of other prime numbers. Okay, so what we can do, so directly actually we can go for prime numbers. We need not to check for one, we need not check for all the numbers. They're telling some prime numbers can be expressed as a sum of other consecutive prime numbers. Yes. So yeah, Srija has given some code. Okay, we'll see. Okay, so whether it is working or not. Okay, fine. Yes. So we'll see what is the logic. So if you observe, it is not all the numbers. So it is only prime numbers should be expressed as sum of other consecutive prime numbers. Okay. So that two consecutive prime numbers. They are telling consecutive prime numbers. What is the meaning of consecutive? Can anyone tell me what is the meaning of consecutive? Yes. Okay. So exactly. Okay. So what is consecutive? Consecutive is nothing but adjacent numbers. For example, uh, 2 and 3 are consecutive numbers. Yes. Yeah. Side by side. Shravanti. Yes. Okay. So consecutive are nothing but next number. So for example, I can tell 2 and 2, 3, 4 are consecutive. Okay. Continuous numbers. Yes, Anusha. Okay. Uh, yeah. So I should find out prime numbers can the count of prime numbers which can be expressed as sum of other consecutive prime numbers. So if you observe here, I am purely working on only prime numbers. Yes. So actually, I need not to worry about other numbers at all. Okay. So what I'm doing? So first, what will I do? So until this n value, so they gave n value as 20, right? Okay. So until 20, I'll store all the prime numbers. Okay. So can anyone tell me what are the prime numbers we'll get until 20? Okay. So 2, yes, 3, 5, 7, 11, 13. Okay. So 14, no, 15, no, 17. That's it. Yes. So first, what will I do? What is the logic? What I'm going to do? So here I'm purely working on prime numbers. So I want prime numbers. Okay. So as a sum of other prime numbers. Yes. Yes, Anushma. 3, 5, 7, 9. Sorry, 9 is not a prime number. Okay. 3, 5, 19 also. Yes. Thank you. Thank you, Shravanti. Okay. Even 19. So 2, 3, 5, 7, 11, 13, 17, and 19. Yes. Okay. So these are the prime numbers. So in these prime numbers, what should I do? I should find out. Okay. So sum of consecutive prime numbers. Okay. So I should find out a number of prime numbers which can be expressed as a sum of consecutive prime numbers. I cannot take 2 and 7. Okay. So for example, okay. So I cannot add 3 plus 7. I cannot take 5 or 11. Okay. So I cannot take 11 and 7. Okay. So I should take only adjacent numbers. Okay. So because they are telling consecutive prime numbers. Yes. Okay. Yeah. So now, okay, fine. What we'll do, so we'll take one array. Okay. So in that array, we'll store all the prime numbers. This we can easily do. Okay. So then tell me after that, what can we do? So I'll be taking all the prime numbers. Okay. So whatever may be the n value. Okay. So we'll until that n value, what are the prime numbers we are getting, we can store it. Okay. So after storing this, uh, what can we do? Yes. So what is the logic? What logic can we apply, or so that I'll get the count of prime numbers which can be expressed as a sum of other prime numbers. Yes, any logics? What can we do? So here, and one more thing, if you observe, there is no condition that you should take only two numbers, you should take only three numbers. You can take any number. Yes. So you can take any number, like two numbers, three numbers, four numbers, five numbers, six numbers. If they're telling only two numbers, actually I can check. I can first see 2, 3, 3, 5, 5, 7, 11, 17, 11, 13, 13, 17, 17, 19. Okay. If they're telling only two numbers, I would have done this. Okay. So they did not tell we should take only two numbers. They did not tell we should take only three numbers. Okay. So, but they gave one condition. What is that condition? It should be only adjacent numbers. Okay, so only it should be adjacent numbers. So actually, because of these adjacent numbers, only question become very easy. Okay, so can anyone tell me what logic I can apply here? Yes, anyone? So we'll be storing all the prime numbers. After that, what can we do? After storing all the prime numbers, what can we do? Yes. Okay. So yeah. So see these numbers. So 5, 2, 3, 5. Okay. So first, let it be. Okay. And can I take two? So for example, first number. So here, what is the first number? First number is 2. Okay. So first number is 2. Yes. So can I count this into output? Can I count 2 as the output? So for example, can I take 2 into consideration for the count of the output? Actually, no, because they are telling constraint that summation should always start with number 2. So in the range of 3 to n. Okay. So now the task is to find out how many prime numbers. Okay. How many prime numbers which satisfy the property that are present in the range of 3 to n. Okay. So from 3 to n, whatever maybe the numbers are there with these properties. Okay. So that count we should find out. Yes. Okay. So what I'll be doing. So I want all the adjacent numbers, right? Okay. Yeah. Yes. Okay. So what I'll be doing. So just try to add all those numbers. Okay. So for example, 2. Yeah, Anish is telling add a consecutive number till the sum is less than or equal to 20. If it fails, then start from next index position. Okay. Yeah, or consecutive number till the sum is less or equal to 20. Okay. So if it fails, then start from next index position. Okay, fine. Yeah, we'll try to do almost same thing. Okay. So first, what will I do? So first prime number, I should start from where? Okay. So I'll be starting from here. Okay. So my first prime number is 2. Okay. So can I count my 2 into the output? No. So even now count will be 0 only. Okay. So they are telling I should start from range 3. Yes. So first number. So I'll take first two numbers, 2 plus 3. Okay. So if I do 2 plus 3, what will I get? I'll get 5. Okay. So whatever the sum I am getting. Okay. So this should be a prime number. Yes. So if this is a prime number, then only I can consider it into count. So if I add 2 plus 3, I'm getting 5. Okay. So is it a prime number? Yes. And can it be expressed as a sum of consecutive prime numbers? Yes. So now my count will become 1. Okay. So next, whatever the sum I am getting. Okay. So yeah, and one more thing. Okay. So if we observe, yeah, we'll come to that point also. So yes. Next. Okay. So next, what will I do? 5. So now I got my sum as 5. Okay. So next, I want consecutive numbers, right? So I'll take next consecutive number. What is the next consecutive number? 7. So 5 plus 7 is 12. Okay. Is it a prime number? You are taking consecutive prime numbers only. So if you observe in this 5, you are taking these 2 and 3 also. Okay. So in these numbers, you are taking 2 and 3 also. Okay. So even those 3 numbers are also considered. Yes. Okay. So here and coming to this 12 is not a prime number, so I'll not increment my count. So I am crossing it. Okay. So next. Okay. So next I'll be taking one more number. What is the one more number? 11. Okay. So next my number becomes next I should add 2 plus. Okay. Sorry. 2 plus 3 plus 5 plus 7 plus 11. So and if you observe every time you need not to do all these things. 2 plus 3. Okay. So plus 5 plus 7, all those things actually. So yeah, all these things. Okay. So all these things actually we can get it here only. Okay, 1 minute. Yeah. Yes. Okay. Give me 1 minute. People are asking me. They're trying to enter. Okay. Let me check. Okay. So 1 minute. Give me 1 minute. Yes. I hope everyone can hear me, right? Yes. If you cannot hear me, please tell. Please tell me. Okay. And I can see my screen also. I hope. Yes or no. Some people are telling they cannot see it. Okay. So can everyone hear me? And if everyone can see the screen, then we'll proceed. Okay, fine then. Okay, so yeah, let us continue. Okay, so I'll be taking what I'll be taking. I'll be taking all the prime numbers. Okay, so let us start. I'll be taking all the prime numbers. Okay, so after taking all the prime numbers, what will I do? I want consecutive numbers. So what will I do? I'll keep on adding all the numbers. I'm rightly telling logic. Okay, so keep on adding all the numbers. Okay, so after that, whatever the output you get, so check if this is a prime number. Okay, so then increment the count plus plus. If it is not a prime number, then need not to do anything. Yes, so store all the prime numbers. Okay, so after then add each and every number. Okay, so first I'm taking 2 plus 3, so I'm checking with 5. Okay, I'll repeat again. I want all the consecutive prime numbers, right? Okay, so that's why I'll add only consecutive numbers. Okay, so first time only one number. Okay, so that need not to be considered, so I'll not increment count. Actually I should start from 3. So directly I'm starting from 2 and 3. So 2 and 3 is 5. Okay, so after that, so I have checked first 2 numbers. Next, if I want to check first 3 numbers, what should I do? I should add 2 plus 3. Okay, so whatever the number I have, so now if I'm taking all these numbers, okay, so take these 3 numbers and then count. Next 4 numbers and then count. Next 5 numbers and then check. Next 6 numbers and then check. Next 7 numbers and then check. Okay, so instead of doing all these things, what we can do? Okay, so every time. Okay, so whatever the sum we get. So for example, I'm taking yeah. So let me write kind of a logic here only. 1 minute. Okay, so for example, let me take this as an array, and here my size as k. So let us take there are k elements. So now what should I do? I should add all these elements and then check whether it is a prime number or not. If it is a prime number, then increment the count. If it is not a prime number, okay, so then don't increment the count. So for that purpose, I am writing a loop. Okay, so for I is equal to 0, I less than k, I plus plus. Okay, so how we are forming this array and how we are getting the size, we'll see. So for now, let us assume whatever the number they gave. Okay, so we found all the prime numbers. Okay, we are storing all the prime numbers in an array, and we got size as some k. Okay, so now here what should I do? So I should add all these numbers and then check their sum is prime number or not. Okay, so for that purpose, I'm taking sum initially. Sum is equal to 0. Okay, so yeah, so here I'll keep on adding it. Okay, so first time. Okay, so in this I'll add sum is equal to, okay, so sum is equal to sum plus a of I. Okay, so what happens, so every time I will be adding new number to this number, so add first number. Okay, for example, okay, so see here, so first time what will be my sum? First time my sum will be 2. Okay, so after this I should check whether this is a prime number or not. Yes, if this is a prime number I should increment. If this is not a prime number, okay, so then what should I do? Okay, I should not increment the count. So for that purpose I'm checking c is equal to, okay, so let us take prime as some function. Okay, we'll write this function also. So c is equal to, yeah, c is equal to prime of sum. So now what happened, so this prime is a function. Okay, this will return. So if this is a prime number, my c value will be 1. Okay, so if it is not a prime number, my c value will be 0. Okay, so after this I'll write a condition. If c double equal to 1, when my c value will be 1, okay, so whenever the sum is a prime number, my c value will be 1. Okay, so when if my c is equal to 1, then increment count plus plus. Okay, so and then close. Okay, so after the at the end print c plus plus or whatever may be the c value. So if you observe what I'm doing, I'm taking all the prime numbers and adding each and every number. After adding each and every number, I'll get a sum. So that sum I'm checking whether it is a prime number or not. If it is a prime number, increment the count. If it is not a prime number, then don't increment the count. Okay, so here we need to add some more conditions. Yes, okay, so yeah, we need to add some more conditions. We'll see what are those conditions when we are writing a program. Okay, so this is the logic for this program. So if you have understood the logic, yes. If you did not understand the logic, please tell me, I'll repeat it again. Okay, so what I'm doing, I'm taking all the prime numbers in an array. After then add each and every number and then check whether it is a prime number or not. If it is a prime number, then increment count. If it is not a prime number, don't increment the count. Okay, so that is what I'm doing. So this logic is not perfect. We need to make changes to this. We need to make changes to this code. Okay, so we'll see all those things. So I hope everyone is clear. Yes, if you have any doubt with the logic, please tell me. If you have any doubt with the logic, please tell me. What I'm doing, taking all the prime numbers in an array, add each and every number, and then check whether it is a prime number or not. Okay, so if it is a prime number, increment the count. If it is not a prime number, then don't increment the count. That's it. Okay, so yeah, so let me 1 minute. Okay, let me remove this and start writing a program now. So I'll write a program, don't worry. Okay, so even if you have any doubts, all those things will be cleared when I'm writing a program, or if you did not understand the logic, please tell me. Okay, so fine. We'll start writing code. So directly I'm starting from main function. I'm not writing hash include all those things. Okay. First, so if you observe here, we are using prime function, right? So I told we will be using the prime as a function. So before that, I should first I'll be defining this prime function. So I hope everyone knows the logic of a prime number. I'm not explaining the logic of a prime number. So directly I'm writing a prime number logic. Okay. So if there are any people from civil and mechanical, yeah. So I'm directly writing. Okay. So what is I'm taking my function as a, okay. So yeah. Yes. Okay. So main logic is what will be starting from. I'm writing a for loop for. Okay. So if I want to check for a prime number, I should start from 2. Okay. So there are so many logic. You can start from 1. You can start from 2. You can start from n. You can start from n by 2. Okay. So here I'm starting from 2. Okay. So realize the answer. So can anyone tell me why I'm checking only for up to half of that number? Yes. I hope you know this, but okay. So can anyone tell me why I'm checking only up to half of this number? So this is just prime number logic. So instead of checking, so if I want to check whether a prime number or not, what should I do generally? Okay, so I should start from 1 and I should start from 1 and should check up to n value. Okay, so in that if it has more than 2 factors, okay, then it is not a prime number. Okay, so but instead of doing all those things, what I'm doing, I'm directly checking from 2 to n by 2. So if I'm checking for 2 to n by 2, okay, so then tell me when can I tell that my number is not a prime number? Yes, any answers? I hope okay, so I hope everyone understanding it. So why I'm writing j is equal to 2y. Okay, uh, okay, so if not, please tell me. I'll explain again and again. So I should declare what are the variables I'm taking here. So I took g, I took sorry, j, c. So b is already declared, right? Okay, so let it be. So initially I'm making c is equal to 1. So initially c is equal to 1 whenever, so if you observe any number. Okay, so can anyone tell me why did I take b by 2? Yes, in this prime number logic, I took b by 2. Yes, should I explain or you know it? Yes, any answers? Yeah, so fine, I'll tell you. Okay, it will just take 2 minutes. Okay, so if I take it number called 12, can you tell me what are the factors? 1, 2, 3, 4, 6 and 12. Okay, so if I take a number called 8, 1, 2, 4 and 8. Okay, so any number you take. Okay, so even if I take some odd number, okay, so let it be 15. 1. Okay, so 1, 3, 5, 15. That's it. Only 4 factors, right? Okay, so yeah, any number you take. Okay, so after this half of this number, so half of this number is 6. 8 half is what? 4. 15 half is 7.5. Okay, let it be. So I'm taking this number. So if you observe, after the half of this number, I'm getting only one factor. What is that factor? Same number value called n. Yes, any number you take. Okay, so after the half of the number, you'll be having only one factor. That is the same number. Okay, so that's why actually you need not to check all these numbers after this n by 2. Okay, so that's why I wrote j less than or equal to b by 2. Why did I write j less than or equal to b by 2? I am checking only up to half of the number. Okay, so because this will reduce me almost half of the time in each and every iteration. Okay, and one more thing, for every number, first one will be common. So you know that this number is common for every number. So that is why what I'm doing, I'm starting from, I'm not taking 1. Directly I'm taking 2. Okay, so I did not include 1, I did not include n. Okay, so for example, if I take a prime number, it will have only 2 factors, 1 and 7. Yes, 5, 1 and 5. I did not include this number. I did not include this number also. Yes, I did not include the first number and I did not include the last number. So if you observe, my number should never be divisible by any other number. Okay, so if it is a divisible, then I can decide that that is not a prime number. For example, 8 is divisible by 4. So it's a prime number. 15 divisible by 5 and 3. Not a prime number. 7. If you observe, I did not consider 1. I did not consider n. So these numbers should never be divisible. Okay. So yeah, that is what the logic which I'm taking here. Okay. So b modulo j is equal to 0. So whenever it is divisible, it is just a kind of a flag. Okay. So I've taken c is equal to 0. So after this, I'm writing a condition. If okay, so if c double equal to 1, so what does that mean? If c double equal to 1, if c double equal to 1, then it represents what? Okay, so it represents that it is a prime number. Yes, so if c double equal to 1, that means it is not divisible by any other number, so it represents a prime number. So for that reason I am writing okay, so sorry, if c double equal to 1, this is a function, right? So I am writing return 1. Okay, so else, okay, else return 0. Okay, so if you observe, what is this? This is a function. Okay, so whatever thing I wrote, prime is a function. What it does, it will take the input. If it whatever the number you have passed, if it is a prime number, it will return 1. Okay, so if it is not a prime number, it will return 0. Yeah, so this yes. Okay, so brackets are correct. Open close, fine. Okay, so this is the prime function. Okay, so after that, now we'll see main program. So they'll be giving us only one input. Yes, what is that input? N value. So I'm declaring int n. Okay, so scanf. So if people write down correct syntax, I'm just telling, I'm just writing normally. So scanf ampersand n. Okay, next what should I do? Okay, so next what we did, we created an array of all the prime numbers. Okay, we created an array of all the prime numbers. After that array, then we checked, we kept on adding a number, and then we checked whether the sum is prime number or not. Okay, now first let us create an array. Okay, so let us create an array, and then okay, so and then we can check whether the sum is prime number or not. Okay, so yeah, so for that purpose I am taking a loop. Okay, so because I should start from 2 to n, right? Okay, so yeah, for I is equal to 2. Okay, I less than n. Okay, I is equal to 2. I less than n until that n value. Okay, so less than or equal to, I should consider that last value also. So until that value. Okay, so what I'm doing, I'm trying to make it an array. Okay, so fine, we'll see what should be the declaration, all those things for an array. Okay, so in this, okay, so in this what I'm doing, if, okay, so if a number is prime number, then that should be stored in an array. Yes. Okay, so what should be the size of an array? So can you tell me what should be the size of an array? Yes. Okay, so if you observe, yeah, here they did not, they gave some n value as a very big number. Okay, so assume array size as a lesser number first. Okay, so randomly, so assume, so first I'm taking my array size as 100, for example. Or if you want to go with the dynamic programming, you can go with, sorry, dynamic memory allocation, you can do that also. Okay. Fine, even dynamic allocation, if it is a C language, actually what we'll be doing, so every time we should use realloc. So instead of that, what we'll do, so I'm taking one number called 100. So I'm declaring a size of array as 100. Okay, so if it is giving, if you are not, if all the test cases are not getting passed, then try to increase that array size. Okay, so yeah, for I is equal to 2, I less than or equal to 1, if. Now I should check whether a number is prime number or not. We have already written a function, so I'm writing if prime of I. Okay, so yeah, so what is this if block? So whenever my number is a prime number, condition will be satisfied. Yes, so if it is a prime number, that should be stored in an array. Okay, so that I'm storing in an array. Then tell me what should be my index value. So for example, a of yeah, so here what should I read? So initially I've declared of 100, fine. Okay, so first value should be stored in 0, second value should be stored in 1, third value should be stored in 2, and so on. Yes, so for that reason what I'm doing, I'm taking one more variable, k is equal to 0. Okay, so I am writing k plus plus plus. Okay, so I hope everyone knows what is this k plus plus. K plus plus is a post increment thing. Okay, so after storing a value, okay, so for example, first time 2 is a prime number. Yes. Okay, if of 2, is it condition satisfied? Yes. So now 2 will be stored in a of 0. Okay, so after then k value will be incremented. Yes, I hope everyone knows what is this k plus plus. Yes, so first time k will be 0, so 2 will be stored. After this k plus plus, so now k becomes 1. Okay, so next time in a of 1, next prime number will be stored, that is 3. After then k plus plus. Okay, so and then k becomes 2 post increment. So first use that value and then increment that value. Okay, uh, fine. So now what is this for loop does? Okay, so this for loop creates an array of all the prime numbers. So from 2 to n, whatever may be the prime numbers you have. Okay, so whatever the prime numbers you have, so it will create an array. This for loop will create an array. So check whether it is a prime number or not. If it is a prime number, store it in array. If it's not a prime number, then don't do anything. Okay, so can anyone tell me how can I find array size? Yes, so you have stored all the elements. Yes, it's okay. Okay, so now if I want access all those elements, it is starting from 0, I know. Okay, so yeah, then how can I find this array size? So it's very easy. I hope everyone knows it. So how can I get this array size? Yes, any answers? How can I get this array size? I'm storing all the elements in an array. Okay, so how can I get this array size? Exactly. Okay, so yeah, 227 is telling length. Okay, that's what. How will we get that length? Okay, so how will we get that length? Exactly, Srija, k value. Okay, so k value gives us length because every time you're storing a value, k value is getting incremented. Okay, so yes. Okay, so for example, let us take I'm storing two numbers. Okay, so instead of or Shraddha is telling size of array by size of array of 0. Okay, if you want, we can do that also. Okay, actually, why this k itself gives us this array size? Yes, because we are using a variable. We need not to find out our total array size by size occupied by each element. Actually, not required. Okay, so k value itself gives us the array size. Okay, so now we got an array. Then what we should do? Okay, so after getting an array, the logic which we wrote previously. Okay, so add every number. So for example, here. Okay, so for example, I got 2, 3, 5, 7. Okay, 11, 13, 17, 19. Okay, so I've stored all this value in this array of A. So now add each and every value and check whether it is a prime number or not. Yes, that's it. So if we can do that, then our work is done. Yeah. So after that, I'm checking for. So the loop which we wrote previously. Okay. So can I use again I variable? Previously I have used I variable. I'm using I variable again. Will it show any error? Yes. I'm using I value again. Will it show any error? No. Exactly, Shisha, it will not show any error because scope is different. Inside a I loop, I cannot use I loop again. Yes. Okay. So here you should get one doubt. So if it is storing these elements, can you tell me what will be the k value? So after storing this one, so 1 minute. Okay. So here after storing this value 0, k becomes 1. After this, k becomes 1, k will be made as 2. Yes, right, k plus plus. So Yes. Yeah. Because yes, that's what I wanted to tell actually. Okay. So if index elements are 0, 1, 2, 3, 4, 5, 6, 7. Sorry. 0, 1, 2, 3, 4, 5, 6, 7. Okay. So if it is 1, my k value will be 2. If it is 2, my k value will be 3, 4, 5, 6, 7, 8. Okay, so k value becomes 8. That means there should be 8 elements. Do we have 8 elements? 1, 2, 3, 4, 5, 6, 7, 8. Exactly. So you need not to worry about, so this k itself gives us the size. Okay, so if you have a doubt, then check this thing. Okay, that's what some people have asked me. Sir, k value will be incremented, right? So size value should be decreased. No. So if there are, if my index value is 7, then obviously there will be 8 elements. So directly I have written I less than k. Okay, so that means from 0 to 7 value, but my k value will be 8. Okay, so in this what should I do? So now add each and every element. Okay, so I am writing sum. Sum is equal to sum plus, okay, so a of I. Sum is equal to sum plus a of I. So initially I should have declared this sum variable. So what happens? So should I initialize this value or I need not to initialize? Okay, so if I don't initialize, what happens? So for example, here I did not initialize. Okay, so will it create a problem? Yes or no? So I've taken sum is equal to a of sum is equal to sum plus a of I. Yes, yeah, exactly. Okay, will it create error 530 is telling no? Okay, so definitely it will be a problem. Okay, so it will be a problem because this sum is a local variable. Yes, sum is a local variable for this function. So what is the default value of a local variable? What is the default value of a local variable? Exactly. What Sija was telling, garbage value. What is the meaning of garbage value? It will take some random number. So it might take whatever may be the range of this integer. It will select some random number. So here you are adding a of I to some random number. Then obviously your output will be affected. So for that purpose, whenever you are taking any local variables and you are adding something, if you are initializing, no issues. So for example, for n here I have initialized. Even that there was garbage value, I have made it as some n value. But here, if you're adding that thing, then definitely value should be initialized. Okay. So can anyone tell me what is the default value of a global variable? Yes. Default value of a global variable, exactly, it's 0. Okay. So if it is a global variable, that will be above this main function. Yes. Okay. So if it is a global variable, you need not to worry. As it is a local variable, you need to worry about it. Okay. So I'll be adding first 2, 3, 5, and so on. Okay. So after this, what should I do? Now I should check. Okay, so if of, okay, so if of whether that is a prime number or what. Okay, so yeah, so I'm writing if of uh, prime of sum. Okay, so again, whatever the variable I'm getting each and every time, I'm sending it for prime function. Okay, so what this prime does? If it is a prime number, it will return 1. Okay, so if it is not a prime number, it will return 0. Sir, did not declare I. Yeah, thank you. I did not declare I. Let me do it. Okay, fine. All these things actually our compiler will tell whenever at the time we can modify it. Okay, fine. No problem. We have declared I. Okay, so sum is equal to sum plus I. Here also, yeah. So this if when this condition will be satisfied, if my number is a prime number, if sum is a prime number. Okay, so after that, if it is a prime number, then what should we do? Okay, so if it is a prime number, then I should increment the count. Yes, C plus plus. So initially, obviously, so initially I should declare a variable, and again say my count should be made as 0. Okay, so then tell me, will this work or not? So after this, I'll be, if I print C value, okay, will it give us the correct output? No, it will not give us the correct output. Can anyone tell me why? Yes, Sharwani, it will not give us the correct output. Okay, so can anyone tell me why? What I'm doing, I'm adding each and every value. Yes, So each and every value and check whether it is a prime number or not. If it is a prime number, then I'm incrementing the count. At the last, print this count. Okay. So then what are the things we are missing here? Yes. What did we miss? So what are the conditions we should add in this? Yes. Any answers? Okay. Yeah. So if you observe first thing, here we are starting my number from 2. Yes. Okay. So let it be. So here my for loop will be ended, right? So yeah. Next. Okay. So next, if I'm writing a printf function, so printf. Okay. So printf percentile d comma c. Okay. So yeah. So first thing, if I print count, okay. So let us check. Okay. So if I give my value as 5, okay. So if I give my n value as 5 here, okay. So if I give my n value as 5, what should be the output? Output should be 1. But your code will give us, but this code will give us 2. Yes. So if n is equal to 5, okay. So if n is equal to 5, output should be what? Only 1. But this code will give us 2. Okay. Can anyone tell me why it is giving us 2? If n is equal to 5, output should be 1. But this count will be 2. Can anyone tell me why here output will be 2? Yes. Any answers? Exactly, Srija. That is because we are starting from 2. Okay. So my array element is starting from 2. Yes, 2 should not be included. So if you observe, I'll be storing 2, 3, 5. My array size will be this. So if I take n is equal to 5. So first time, what happens? So first time sum is equal to 0 plus 2. First number is 2, right? So after that, I'll check. Is 2 is a prime number? Yes. Then my count will be incremented. Next. Okay. So what happens? Next, I'll add. So yeah. So next, I'll take 2 plus 3. So what is 2 plus 3? 5. Okay. So 2 plus 3 is 5. Is 5 is a prime number? Yes. C plus plus. So now my count became how much? My count became 2. Yes. So if you observe, in the question they have mentioned. Okay. So in the question they have mentioned. What did they mention? They have mentioned that you should consider, you should print the range only from 3 to n. Yeah, this line. That's why I'll tell, please read the question carefully. From 3 to n. Okay, so range from 3 to n. That means I should not consider a number from, I should not consider second number. I should not consider number 2. Okay, so yeah. So can I start here my loop from 3? So they are telling should not consider 2, right? Okay, so they are telling should not consider 2. So can I start? Okay, so can I start my loop from 3? I is equal to 2. They are telling should not consider 2. Yes, so print ranges from 3 to n. So range, they're telling print from 3 to n. 3 to n. So can I start I is equal to, from I is equal to 3? Yes or no? Please check. Exactly. We cannot start from I is equal to 3, because if we start from I is equal to 3, then even 5 will not be satisfied, because 5 can be written as 2 plus 3. We need 2 here. 2 should be there, but that should not be considered into the count. Yes, Shraddha, I hope you are clear. Yes, okay. I should start from 2 only, but that thing should not be counted. Okay. So for that reason, actually, we are getting one number extra every time. Yes. So for that reason, what I'm doing, for that reason, after finding the output, okay. So I'm writing C minus minus. Okay. So I'm starting the loop C minus minus. Yes. Either we can do this, or CJ is suggesting start, instead of starting I is equal to 0, start from 2 and then make sum is equal to 2. Yeah, even we can do that, no issues. Okay, uh, fine. Will this give us the correct output? No, still it will not give us the correct output. Please tell me why. Okay, so yes, give me 2 minutes. Check. Still there is some error with this code. I'm telling only with this thing. Okay, so please tell me why it will not give us the correct output. Give me 2 minutes. Okay, please. Yeah, uh, still this program will not give us the correct output. Still, what are we missing? Yes, what are we missing here? Yeah, still we should include something in this. Okay, so what are we missing? She's just telling if we give n as 3, it will give us output as 1. Should not happen. So check, will it give us output as 1? 1 minute. Okay, so if I give n value as 3, okay, so what will my array? My array will be 2 comma 3. Yes, so after this it will start from 0. So initially sum is equal to 0 plus 2. Okay, so as 2 is a prime number. Okay, so as 2 is a prime number, count will be 1. Next, uh, next, yes, okay, so c is equal to, next what happens? Next we'll add one more prime number, 2 plus 3, 5. Okay, so is 5 is a prime number? Yes, count became 2. After this we are printing print c minus minus. If you print c minus minus, it will give you 1. Yeah, so yes, exactly, even though we are giving 3, it is giving count as 1. Sorry, it is giving count as 1, but it should give us 0. Can you tell me what, where are we missing? Exactly, so if you observe this 5. Okay, so they are telling the range. So if you read the question carefully, that is what. So if you read the question carefully, I want a numbers ranging from 3 to n, but 5 does not come under this range, right? Because n value is 3 only. Okay, so yeah, so we should include this condition also when you are adding. Okay, so if your sum is crossing n value, then you should not consider that number. Here n value is 3 only. Yes, 5 is also a prime number. Yes, that's correct. Okay, and also that can be expressed as sum of two prime numbers. Yes, but this 5 does not come under this range, right? Okay, so we should include that condition also. Okay, so then tell me, where can I include that condition? I'm including it here. If it is a prime number, and okay, and my number should be less than or equal to the 10 value. Yes, so yeah, so then tell me what condition I should write. So first thing, you should check for prime number, it is a prime number or not. Okay, so after checking a prime number, you should also check whether that number is less than or equal to your n value or not. Sum is less than or equal to n value, then only increment the count. Yes, okay, exactly, Srija and Shraddha, that's what. Okay, so if you observe here, so now let us check for the same case. Okay, so first time. Okay, so now after the condition we'll see. Okay, so count is made as 1. Yes, count is made as 1. So now 2 plus 3 becomes 5. Okay, so is 5 is less than or equal to n value? No. Yes, It should be prime number and should be less than n. So now what happens? So now my count will not be incremented. Yes. So even here my count will be 1 only. Yes. So at the end I'll print c minus minus. So that will give me the output called 0. So if you observe 3, there are no numbers which can be expressed as sum of prime numbers. Yes. Yeah. This is the code and logic for this program. Yes, I have written by using C language because everyone will have a knowledge on C language. Okay, so that is why I have took C language. So if you have written by using any other language like Python, because you have learned when you're learning InfiniQ, okay, so that's fine. So if you have written, if that code is giving you output, no worries. So if you have a doubt whether your code is correct or not, then send me, I'll check. Okay, so yes, this is the code. So if you have any doubts, please ask. If not, we'll move to next question. Yes, shall we proceed to next question? Yes, I have written entire code. This will work surely. Okay. So shall we move to next question? Yes or no? Any answers? Am I audible? Yeah. Okay. Okay. So now tell me. Yes. Yes. Thank you. Thank you. Should we discuss another question or should we discuss introduction to one algorithm? Okay. So actually, I thought if I discuss only algorithms, again theory will be bored. So I thought we'll discuss one question, one algorithm. Okay. So some people are telling question, some people are telling algorithm. Okay, fine. We'll solve one more question. After then, we'll see algorithm. Okay. So most of the people are telling question. Okay, fine. We'll discuss one more question. After then, we'll go for algorithm. You should have an idea about algorithms also because those are important actually, especially in Codevita. Okay, fine. This is the second question. Yeah, try this question. I hope I can see the question right. So read the question and try to understand. Okay. Yeah. What's the question? Actually, the question is kth highest factor. Please read the question and try to understand. Main thing, if you need to write a program first, you should understand the question. Yes. Without understanding, it is not possible to write a question. Yes. Yeah. Read the question. Yes. There is some sample input and output also. Excuse me. Okay. Shall we start? Okay. Fine. Let me read the question for you. Okay. Kth highest factor, a positive integer n, a positive integer d is said to be a factor of another positive integer n if when n is divided by d. Okay, factor fine. The remainder obtained is 0. Okay. I hope you know what is a factor. Yes, a positive integer d is said to be a factor of another positive integer n. Another positive integer n if when n is divided by d. The remainder obtained is 0. Fine. That is what actually the factor is. For example, the number 12, there are 6 factors 1, 2, 3, 4, 6, 12. Every positive integer k has at least 2 factors. Exactly. Every positive integer, minimum 2 factors, 1 and itself. Okay. So 1 and the number k itself. Given 2 positive integers n and k, write a program to print the kth largest factor of n. Okay. So I should print kth largest factor input format. Input format, the input is a comma separated list of positive integer pairs n comma k. Okay. So your input will be n and k. Okay. Next, output format. Output format will be k is highest factor of n. If n does not have k factors, then output should be 1. Okay, fine. Okay, so constraints, they have given constraints for one value, sorry, n value and then k value. Okay, so you can assume that n will have no prime factors which are larger than 13. Okay. So you can assume that n will have no prime factors which are larger than 13. Fine. Okay. So sample input 12 comma 3. Okay. Sample output is 1. Yeah, they're explaining also. So if you observe, if you see the question, I hope everyone understood the question. Okay. So n is equal to 12. So what are the factors of 12? 1, 2, 3, 4, 6, and 12. Okay. So yes. So 1, 2, 3, 4, 6, and 12. Okay. So if my k is equal to 1, what should be the output? Yes, anyone? If k is equal to 1, that means I should print first highest factor. Yes, if k is equal to 1, my output should be, sorry, if k is equal to 1, my output should be 2. Sorry, 12. If k is equal to 2, my output should be 6. Funny Kumar, please check kth highest factor. Okay, so yeah, that's why please read the question. I hope Funny Kumar, you are clear what I'm trying to tell. Okay, so when k is equal to 1, output should be 12, not 2. When k is equal to 2, second highest factor. This is the second highest factor. Okay, so when k is equal to 3, third highest factor. Okay, that is 4, and so on. Okay, so for example, when k is equal to 10, what should be the output? Yes, everyone. When k is equal to 10, what will be the output? Any answers? Please read the question. Yes, exactly. Exactly, Srija, it is 1. So here they are mentioning. So if you observe, if every positive number itself given to positive integers and here write a program. Okay. So somewhere actually they are mentioning. Okay. Read the question properly. Every positive integers k has at least two factors, one a number k itself given to positive integer k. Write a program to print kth largest factor. Yeah, here. If n does not have k factors, then output should be 1. Yeah. Vinod, please mute yourself. Yes. Thank you. Okay. Yeah. When k is equal to 10, I don't have 10 factors, then my output should be 1. Exactly. Okay. So this is the question. Actually, the question is very easy. Yes. So just find out factors. Normally, they'll ask from starting. Now they are asking from the ending. So now tell me, what should we do? I hope everyone understood the question. I'm clearing this. Okay. So still, if you did not understand the question, please ask. If you have understood the question, tell me the logic. What logic can we implement? Yes. Anish is telling make an array of factors of n and then pick the length of the array of kth element. Find factors and append it to array. Okay. So everyone is telling uh, store all the factors in an array. Okay. So if you observe, actually, why we need to store all the arrays? Sorry, why we need to store all the factors? So if you observe, if I start storing and then searching, so my time consumed will be more and also space will be more. So why should we create an array? Yes, actually, we are not working with all those. We are not working with those factors, right? I just need to print a factor. Yes, so actually not required. So we need not to create an array. Okay, so and then store and then print n minus k. Yes, length minus k. That also we can do, but why to declare a separate array and then store? Okay, so we can do without, so try the logic without storing it or without appending it, whatever. Okay, so check, try the logic where no need of appending or no need of storing these array elements. Yes, any logics? Uh, yeah. Uh, yes. If I need, if I am storing, if I so understand this clearly. Okay. So why we are storing actually? So many people are answering, sir, store the array and then exactly store the array and then print last from last print that particular number. So instead of that, exactly, Sricha, that is what I was actually expecting from you people. Okay, so instead of starting, for example, 12 for 12, instead of finding factors from 1 2 3 4 6 and 12. Okay, so instead of starting from the beginning, okay, so can I find factors from ending 12 6 4 3 2 1? Yes, I can do this, right? Yes, so instead of finding a factors from beginning 1 2 3 and then print n minus k. So if I am doing this thing, so I can print length minus k, length minus kth factor. Okay, so for example, here what is the length? 1 2 3 4 5 6. So if I want the last factor, 6 minus 6, kth highest factor, 6 minus 1. So if this is k value, so if I want to print, if I'm finding factors from beginning, then I should print length minus k. So instead of doing this, find factors from the end. Yes, and then make a count. So this becomes 1. So when k is equal to 1, print this. When k is equal to 2, print this. When k is equal to 3, so just keep a count. So C++, whenever it is equal to k value, print that value. Exactly, Sija. Okay, so this is what actually we'll be doing. Yes, I hope everyone understood the logic. Yes, I hope everyone understood. Yes or no? Please respond. So instead of starting from 1 to n, I'm starting from n to 1. Yes. Okay. So here start from n to 1 and then print. So whenever your k value is equal to that particular count, print that value. Okay. And here we can still do one more optimization. Yes. So I can reduce my iterations to half. So here I'll be going with n iterations, right? Okay. So here I'll be doing n iterations. I can make this as almost half or n by 2 plus 1. Can anyone tell me what can we do? Okay. So normally what I'm telling to write a loop from for I is equal to n, I greater than or equal to 1, I plus plus. Okay. So if it is a factor, then increment count. Okay. So if c double equal to k, then print. This is what I'm telling in this logic. Okay. So here you will be doing how many iterations? N iterations. Okay. So we can reduce these iterations to half. So tell me, how can I reduce these iterations to half? Actually, we have discussed the logic previously. Exactly. Okay. So yes. Okay. So that is what. So if you observe, as we discussed previously, any number we take, after the half of the number will be having only uh, after the half of the number will be having only one factor, 12. So this is n by 2. So if you observe, why to do iterations simply here? However, we'll not be getting any value. So what we can do? Okay. So instead of starting it from I, we can start from n by 2. But if you're starting from n by 2, okay, so we should be careful. Okay. So yeah, I'll tell you what are the changes we should make. Okay. So if you're starting from n by 2, we should add one more condition. Okay, so we'll see what is that condition. Okay, so fine, we'll tell. So for example, if k is equal to 1, okay, so if k is equal to 1 and if I'm starting from n by 2, what will my output? If if k is equal to 1, that means I should print highest factor. I should print 12. But if I start from n by 2, my output will be 6. But I want 12. I should not get 6. Okay. So for this purpose, we should include one condition. What is that condition? We'll see it. Okay. So I hope everyone understood this question. Okay. If you have any doubt, please ask. Okay. So if not, we'll start writing code for this. So it's very easy. Okay. So question looks very big. Okay. 5e8. So whoever is 5e8, please mute yourself. Thank you. Okay. Fine. We'll see the. Excuse me. We'll start writing a code. So I'm starting from main function. Yes. Okay. So what are the things they are giving? They'll be just giving. They'll be giving two values. Yes. So I'm taking int n is one value, k is one value. Okay. So after then scanf. Okay. So scanf percentile d. Percentile d. Okay. Comma ampersand n comma ampersand k. Dot. Okay. So k. So I've taken the input. Yes. After that, what should we do? After taking the input, okay. So next, we have everything right. So directly we should start. We can directly start a loop. Okay. So starting from yeah. Okay. So I'm taking a for loop for. Okay. So I told it is better to start from I is equal to n by 2. Why I'm telling to start I is equal to n by 2? Because we can reduce half of the iterations. Okay. So I'm starting from ending. Okay. So when should I stop? So I should stop at what should be my condition? Whenever I get greater than 0 or less than 0, then I should stop. Okay. So now tell me what should be my condition? So whenever I get a 1, I should stop. Yes. Someone has sent a message. We'll check. Okay. So check k value is 1 or not. Yes, exactly. We'll do that. Yeah, that is what. Okay. So we'll include that condition also, Srija. Okay. So first let me write this. So I is equal to n by 2. When it is greater than or equal to 1, then enter. Okay. So I plus plus. We'll include that condition. Don't worry. Okay. So if you observe here, this will not work. So if k is equal to 1, yes, if k is equal to 1, this will not give us the correct output. Okay. So if k is equal to 1, this will not give us the correct output because we are starting from n by 2. Yes. So for that purpose, here I am writing a condition. What is that condition? If k double equal to 1, then tell me what should be the output? Yes. If it is a k is equal to 1, what should be the output? Exactly. Actually, we need not to do any process. Whenever your k is equal to 1, okay, so directly print this n value. Okay, highest factor. Highest factor will be the same number, right? Yes. So directly I'm writing if k is equal to 1, print n value. Else, come to this part. If k is not equal to 1, then only enter into this loop. Yes, actually this was the problem. So if I start from I is equal to n by 2, the problem is we could not, we will not get the highest factor. So that condition we have eliminated here. Yeah. So if k is equal to 1, print n. Else, then I should find out what number. And here we should, yeah. So we can write either I greater than 0 here or I greater than or equal to 1. Yes, anything is fine. Okay. So yeah. So here, what is the factor? Okay. So any I value, if it divides the n number, if it divides n, then it becomes a factor. So I'm checking that condition. If so, how can I check whether a number is divisible by divisible or not? I'll be checking for remainder. So n mod I double equal to 0. Yes. So whenever n mod I double equal to 0, increment C++. I'm incrementing the count. Yes. So tell me, what should be the C value here? So C value, can I make C value as 0? Yes. Exactly. Okay. So what should be the C value? C value initially should be 1, because so if you observe, I am not considering this condition, right? uh, K is equal to 1, so that I have already written. So if I am coming to n by 2, okay, so that means so if I take numbers, okay, so for 12, so 12 is already taken, so next n by 2 is 6. So by the time I come here, my C value should become 2. Excuse me. Okay, so my C value should become 2. So for that reason, what I am taking, so for that reason, initially I am taking C is equal to 1. Whenever it is divisible, I am making it as 2. Okay, so for that purpose, initially I took C is equal to 1, uh, and then I wrote C++. Okay, so after this, so yeah, so each and every time. So after incrementing E++, what we should do? Sorry, after incrementing C++, what we should check? If we should check whether this count is equal to K or what. If this is equal to your count, if the count is equal to K, then what should I do? Then I should print that particular number. Yes, if it is equal to K, then what? Okay, so if it is equal to K, uh, then print that particular number, whatever the number you got. Okay, so print percentile D comma I. Yes, printf percentile D comma I. Okay, so yes, so after getting a number, actually you need not to do all the iterations, right? So for example, if K is equal to 2, after finding this 2, okay, you need not to find 4 3 2 1. You need not to run the loop until this 1. So what we can do exactly? So we can do print and break. Okay. So here, what if my K value is equal to 10? Am I including that condition? Okay. So what if I don't have those many factors? So for example, if I give K is equal to 100, okay. So here my count number will be equal to 100. So it will not print anything. Okay. So but what should I do? If I don't have those many factors, I should print my output as 1. Then tell me what should I do? How can I include that condition? Yes. If I take this 12 example only. Okay. So if I take 12, if I take this 12 example only, my factors will be 6, 4, 3, 2, 1. Okay. So what if I give my K value as some 100? My output should be 1. But here I'll not get any output. So here for K is equal to 1, for K is equal to 100, it will be no output. Yes. Okay. Yeah. So for that reason, what I am doing, so after checking, I have to 1. So after this, then I can decide. Yes. After this operation, after checking until 1, so after that, you will not have any prime numbers, or sorry, you will not have any factors. Yes. So you'll not have any factors. So now here I'm writing if. Okay. So if, okay, so if your count value is not equal to, so if C is not equal to K, okay, so for example, even after doing all these things for 12, K value will be 1 2 3 4 5 6 6 only. So but my count value will be 6, but K value is 100. Okay, so I can tell 6 is not equal to 100. Then what? Then I am doing printf 1. Yes, directly. Okay, so after everything is done, yeah. Okay, so at the end, there should be return 0. Excuse me. Uh, can you see the screen? Yes, everyone. So here I'll be writing return 0. Yeah, something happened to my laptop. Okay, so 1 minute. Yeah, this is the code. Yes, this is the code for this question. The question is actually very easy. Yes, we are starting from n. So instead of starting from n, we are starting from n by 2. Why we are starting from n by 2? To reduce almost half of the iterations. Half of the iterations will be reduced. Yes. Okay. Yeah. Still, you have any doubt in this question? If you have a doubt, please ask. If not, we'll take a break for 15 minutes. The time is 3:55. Okay. So we'll start at 4:10 again. Yes. So if you have any doubts, I'll be here. Please ask. If not, yeah, you can take break for 15 minutes. We'll take a break for 15 minutes. We'll start the session at 4:10. Yes. Thank you. I'll be muting. Okay. So I'll be there. So if you have any doubts, you can please send a text message. Yes, Shraddha, I have written a code in Python. I hope that will work. Yes, right. Yeah, you're taking a list and you're storing all the values. Fine. For I in range of 1 comma n plus 1, so it will run up to n. So if it is divisible, you're storing in a list. If k is less than length, print that. Okay, print of k. If not, print of 1. Yes, yes. Good, very good, Shraddha. Even Shrija also has written by using Python. Okay. So you're directly printing minus negative indexing. Yes, we can also use store it in a list, and we can also use negative indexing. Yes. Still, if you have any doubts or if you have written code, you can send. Okay. So if not, actually, you can try this question, third question. So if you don't want to take any break, okay, I'm displaying the third question. Please read it and try to understand. Yes. Okay. I will start with the question. I hope everyone have read this question, right? Okay. So let me read it for you for once. Uh, yeah. The problem solvers found a new castle for coding and named as Nick's Castle. Okay. These smart people were given a task to make the purchase of items at the castle easier by distributing various coins with different values. Okay, coins question. Fine. Okay. Rahul has come up with a solution that if we make coins category starting from 1 till the maximum price of the item present on a castle, then we can purchase any item easily. Okay. So any item easily, he added the following example. Okay. Uh, any item easily, he added the following example to prove his point. Okay, so let us suppose the maximum price of an item is $5. Okay, then we can make coins of 1, 2, 3, 4, 5 to purchase any item ranging from 1 to 5. Now Tej, being a keen observer, suggested that we could actually minimize the number of coins required and gave following distribution. Okay, so and gave following distribution is dollar 1, 2, 3. According to him, any item can be purchased ranging from 1 to 5. Actually, yes. So if you want, yeah, we'll discuss this question. Everyone was impressed with both of them. Your task is to help Tej, your dear friend, to come up with the minimum number of denominations for an arbitrary maximum price. Yes. Yeah. Minimum number of denominations for an arbitrary maximum price in casting. Input format, first line contains an integer t denoting the number of test cases. Okay. Next, t lines contains an integer denoting the maximum price of the item present on X castle. Output format, for each test case, print a single line denoting the minimum number of denominations of coins required. Okay. So constraints, they gave constraints for t and some sample input. Okay. So yeah, first line contains integer t denoting the number of test cases. So first line is always number of test cases. Okay. So next for 10 and 5, output should be 4 and 3. Okay. Explanation. Yeah. This is what the question is. Yeah. Sample output. Input 1, output 1 is fine. Okay. So I hope. Excuse me. Okay. So you might have come across this type of questions earlier. Okay. Actually, this is very easy. We'll try to solve it now. So first, let us understand this question. So what is given? So for example, yeah, I just need to find the minimum number of coins. Minimum number of coins. Yes. For example, if here they are giving, yes, if it is a $5. So actually, yeah, if the maximum price of $5, so if you can maintain $1, $2, 3, 4, 5, okay, so you can buy any product. Okay, so actually here they're telling in order to buy 5 rupees, okay, in order to buy a product of 5 rupees, you need 5 coins. Actually, it is not required. We can only buy with 3 products. Okay, so sorry, with 3 coins. For example, 1 comma 2 comma 3. If you want 1 rupee, you have 1 rupee. If you have 2, you have 2. If you want 3, you have 3. If you want 4, you can give 3 plus 1. If you want 5, you can give 3 plus 2. Okay. So and also, so with only 3 coins, okay. So with only dollars, with only these 3 coins, 1, 2, 3. Can anyone tell me what is the maximum number we can get? Yes, with only these three coins, can anyone tell me what is the maximum number or what is the maximum cost of a product which we can purchase? Six. Six. Yes. So what is that? Sum of actually sum of all these numbers. So even six also we can get. Okay. So 3 plus 2 plus 1. Okay. So for example, for 10, so this is what. So in order to get 5 rupees, we can go with all these coins of 1, 2, 3, 4, 5, or we can only just make coin of $1, 2, 3. Okay. So and we just need to find the minimum number of coins required. So maximum can be 5 coins maximum. Minimum yeah, it's actually 1, 2, 3. 1 rupee, 2 rupee, 3 rupee, next 4 rupee or 5 rupee. Whatever. Okay, fine. Yes. So if you observe, yeah, I'm clearing all these coins. So according to Rahul, 1, 2, 3, and so on. Yeah. So if I take these test cases, so first two represents number of test cases. So two test cases. So if it is 10, okay. So if it is 10, how many coins we require? So they are telling 4. If it is 5, minimum we require 3. Yes. Okay. So can anyone tell me what can we do? So what is the idea or how can we approach? So whatever the coins you take, okay. So by using those coins, you should be able to get all the numbers. Okay. So yeah, if you want to get one, you should be able to get one. If you want two, two, three, 4, 5, 6, 7. Okay. So any number of coins you take. Okay. So take some number of coins. They did not tell you should take only 1 rupee coins, 2 rupee coins, 3 rupee coins. Yes. So they did not give you any such constraint that only with these coins. Okay. So try to get the number. So you can assume any coin with any value. They did not mention that you should use only these coins with these values. So you can assume any coins. Okay. So any whatever may be the coin, it can be 5 rupees, it can be only 10 rupees, 11 rupees, 13 rupees, 14 rupees, whatever may be the value of the coin. Okay. So you just need to find the minimum number of coins required. Okay. So tell me, what can we do? Yeah, Srija has already given the answer. Yes, fine. Okay. So remaining people. Yes. How can we approach this question? So I just need some numbers. Okay. So by using those coins, I should be able to get all the numbers possible. So yeah. So what can we do? So for example, okay. So let me check. So if you observe binary numbers, okay. So if there are 2 bits, how many different numbers we can form? Yes. Any answers? If there are 2 bits, how many numbers we can form? Yes. Any answers? Anyone? If there are 3 bits, what is the maximum number I can form? If there are 4 bits, what is the maximum number I can form? If there are 5 bits, what is the maximum number I can form? So we have discussed yesterday all these things. Yes, Rija. Okay. So with 2 bits, we can form. So actually, it is a binary representation. So if there are 2 bits, so it is 00, 01, 10, 11. Maximum number is 3. Yes. So 0, 1, 2, 3. So we can actually totally form 4 numbers. Okay. So if it is 3 bits, okay. So if it is 3 bits, how many numbers we can form? 2 cube 8. So if you observe all these numbers are continuous 0, 1, 2, 3. Next, if it is 2 cube, totally 8. What are those numbers? 0, 1, 2, 3, 4, 5, 6, 7. Yes. If there are 4 bits, okay. So how we are getting 2 cube 8? So if there are 4 bits, 2 per 4. So what is 2 per 4? 2 per 4 is 16. So if it is 16, so you can form from 0 to 15 any number. Yes, exactly, to 31. Yeah. Okay. So if it is 2 per 5, so if it is 5 bits, so 2 per 5, so totally 32. So you can form any number from 0 to 31. So can I use same concept here? Yes. So can I use same concept here? What are the concept which we were using in binary numbers? Yes. So if you observe here binary numbers, we can represent here obviously we'll be having a numbers continuously. So for example, if I take 2 bits, so can I tell these 2 bits are nothing but 2 coins? What should be the value of those coins? Yes. What should be the value of those coins? Actually, here they did not ask value of those coins. So what if they ask you how many, what is the minimum number of coins and what are those values? Then what? Then what will we do? Okay. So yeah. Yes. So if you observe, there are 3 bits. Okay. So totally 2 cube, 8 values you can form. Okay. So and what should be those values? Those values should be actually 1, 2, 4, and 8. 2 power 0, 2 power 1, 2 square, 2 cube. Okay. So if you have, there are 4 bits. So if there are 4 bits maximum, how many numbers you can form? 2 power 4, 16. So maximum 16, that means 0 to 15 numbers you can form. And what should be the value of those coins? So if they ask value, you can tell these things. 1, 2, 4, 8. Okay. So here they are not asking any value. So they are just asking number of coins. So how many coins we require. Okay. So let us see this thing only. Yeah. So if I can represent this 10 in binary format. So represent this 10 in binary format. So obviously, so then you'll come to know how many numbers, how many bits you require. So in order to represent 10, how many bits we require? Yes. In order to represent a 10 in binary format, how many numbers we require? Exactly 4 bits. Yes. So what are those actually? So if you observe 10 in binary format, 1010. So by using 3 bits, definitely you cannot form 10 because 111. Okay. So it will be 4 plus 2. Maximum is 7 only. So if you want 10, okay. So minimum we require 4 bits. So yeah. So can I tell I require 4 coins? Yes. And what should be the value of those coins? Those values should be 1 to 4. Here they are not asking the value of those coins. So need not to worry. Okay. So it is actually represent a number in the binary format. Okay. And then try to find out how many bits are required. So for example, 5. Minimum how many bytes are required? Minimum bits. Sorry. Minimum bits required to represent a number. Okay. So 4, 0, 1. 3 bits. So this is 4 bits. That is what the output is, 4 and 3. It's actually represent a number in binary format. Okay. Actually, the question is actually how many bits are required to represent a particular number in binary format. Yes. So if we can find out that, then our question is done. Even if they ask us what should be the value of those coins, even then we can find out what should be the value of those coins, 1, 2, 4, 8, and so on. Yes. I hope you have understood the question. Everyone, did you understand the logic? So if you have a doubt in the logic, please ask me. Okay. So what I'm actually doing, I'm just trying to represent a number in its binary format. Okay. So because once if I can represent 10 in binary format 1010, so here I will be requiring minimum 4 bits. So by using these 4 bits, I can represent any number from 10 to 1. Okay, so actually if you observe, so if it is a 4 bits, you can represent up to actually 15 values. Yes, but here they're asking 10, but here they're asking for only 10, but minimum we require 4 bits. Yes, okay, so that is what we'll be doing. Okay, so what we'll be doing, we'll be trying to actually we are using binary representation thing. Okay, whatever the logic we were using binary representation, I'm using the same logic. So binary numbers, so that's what. So binary numbers are actually will be having continuous numbers, right? So I'll be using the same logic and I'll be just finding out how many numbers, how many bits are required to represent a particular number. Yes. Okay. So in order to find these bits, we can use yes any logics for this. So how can I find number of bits required? Anyone? Any answers? How can I find number of bits required to represent a particular number? Yes. Okay. Fine, I'll tell you. So for example, okay, so let me take in x is equal to 10. Okay, so I'll try to find out. So x is equal to 10. So what can we do? Okay, so how can we check? How can we find out number of bits required? Yes. So what I'm doing? Yeah. So I'm trying to find out by using. Okay. So just check this only. So for example, if I take 1 minute, someone is asking me to admit. Okay. So yeah, fine, no issues. Okay. So x is equal to 10. Okay. So I'm taking my x value as 10. Okay. So first, first I'll be taking what is the minimum value? So minimum. So minimum is 1 rupee, right? Okay. So for that, I'm taking one variable called add is equal to 1. Okay. So add is equal to 1. So I'll be checking. Uh, yeah. So here my value is 10. Okay. Yes. 1 minute. So fine. Why this add value we'll discuss. Let it be. So okay, fine. I'm starting initially. I'm taking some value as 0. I don't know. I don't know right what should be the value. So initially I'm taking 0. Okay. So I'll be comparing. So if this m is less than this x. Okay. So fine. We'll see what is this m value. Okay. So first time 0 is less than x. Yes. Okay. So that means first I'm taking 0 bits. So let us take this m is a kind of a bits, or m is a value. Okay, so actually this m, what is this m represents? So every time this m represents maximum value, I can represent by using a bits. So we'll find find how can I find this maximum value. Okay, so if you observe, if I try to write 1 2 4 8 16, okay, simply fine. Why all these things? Simply we'll take these values. So by using this one, you'll understand. Okay. So first I'll take value 1. Yes. So x value is 10. Okay. So if this 1 is uh, okay. So if this 1 is less than 10. Okay. So what is the number I okay, 1 is less than 10. Okay. Next. I'll be actually checking this number. So this is the maximum number which we can form by using 1 bit. This is by using 2 bits. This is by using 3 bits. This is by using 4 bits. This is by using 1 minute. 1 2 4 8 16. 1 bit, 2 bit, 3 bits. Okay, 1 minute. Give me. Sorry. Okay. Why all these things? Uh, Even this is not required. Okay, let me take 10 value. 1010. I just need to find how many bits required, right? Okay. So do this right shift operation. So what happens right shift operation? So any number you take, okay. So whenever you do right shift operation repeatedly, so first time if I do right shift operation, it becomes 1 0 1. Okay. So next time if I do right shift, it will be 0 0 1 0. Next time if you do right shift, it will become 0 0 0 1. Next time if we do right shift, it becomes 0 0 0 0. Yes. So whenever your number becomes 0 0, so yeah, here your count becomes 1 2 3 and then 4. Yes. Okay. So first, this is actually very simple. So I'm taking one more value, 5. So what is 5 actually? 4 1 0 1. Every time to right shift. Right shift is actually what you are reducing a number. Okay. So 1 0 1 right shift for one time. It becomes 0 1 0. Next time, do one more time. It becomes 0 0 1. Do one more time. Right shift by 1. It becomes 0 0 0. If you observe, you are doing right shift. When it will become 0, when all the ones are removed. So actually, then that will tell you how many bits are required minimum. Yes, so this is one way. What we can do, just represent a number in binary format and keep on doing right shift operation until you get a 0, because every time you do right shift operation one bit will be removed. So if there are 4 bits, okay, so you'll be doing right shift for 4 times. If there are 3 bits, you'll be doing right shift for 3 times. Okay, so even if my value is 2, okay, so actually this matters, right? Okay, so you'll be doing right shift for 2 times. So every time you do right shift for 1 time, one value or 1 bit will be deleted or 1 bit will be counted. Okay, so this is one way. In one method, what we can do, we can just do right shift operation. Any other method. Okay, so actually I was trying by using one more method. Okay, so let me explain it. Let me think. Okay, and then we'll discuss. Give me 1 minute. Yeah. So let me take initially n value as 10. Okay. So yeah. And initially I'm taking some value m is equal to 0. Okay. So this 0. So first time someone sent a text message. Second sample. Okay, 1 minute I'm showing. Okay. Give me 1 minute. Yeah, this is the second test case. So if you have a doubt, check for these test cases if it is working right shift operation or not. Okay. So what I'm doing, I'm taking n is equal to 10. I'm taking m is equal to 0. So this m is equal to 0 actually will represent maximum number I can form. Okay. So yeah. Okay. So I don't know how many times I should do this process. So every time yeah. So first time it should be 1. Next time it should be 2. Next time it should be 4. Next time it should be 8. Yes. Okay. So and then next it will become 16. Give me 1 minute. I'm trying this logic. Okay. So after this, I'll explain. Okay. So first time I should check whether my value is less than 1. Is it greater than 10? Is it greater than 2? Is it greater than 4? Is 10 is greater than 8? Yes. Is 10 is greater than 16? No. Then I should stop. Okay. So 10 is greater than 1? Yes. So I cannot represent by using 1 bit. 10 is greater than 2? Yes. I cannot represent by using 2 bits. 10 is greater than 3? Yes. I cannot represent by using 3 bits. 10 is greater than 8? Yes. Okay. 10 is greater than 16? No. Then I should stop. We'll see this. Yes. Okay. Fine. I'm taking a look. Why? Okay. So whenever my number m is less than n. Okay. So whenever my m is less than n, okay, that means I cannot find a number. Okay. So for that reason, I'm doing m is equal to m plus add. Initially, I made m is equal to 0, but initially value should be 1, right? So initially, I'm taking add is equal to 1. Okay. So after that, so first time it was 1. Next, I should add 2. So if there are 2 bits, maximum sum will be 3. Okay. So next time 1 plus 2 plus 4. That will be the maximum number I can represent by using 3 bits. Okay. So next time 1 plus 2 plus 4 plus 8. Okay. So that is the maximum number I can represent. So that means this add should change every time by 2. Okay. So add is equal to add into 2. So whenever I'm doing this process, I can increment k plus plus. Okay. So fine. I got this thing. I'll explain 1 minute. Okay. So let us see. One logic is of right shift operation. Okay. So one logic you can do right shift operation. Next, let us see one more logic. So I'm taking n is equal to 10 and m as some value. So initially m is 0. Okay. So actually what is this m contains? So if you observe, if I take bit 0, sorry, not 0. So 1, 2, 4, 8, 16. So yes. So what is this m value? This m value will tell what is the maximum value I can find by using bits. So initially I'm taking it 0. Okay. So initially I'm taking it as 0. Yes. Okay. So first time. So if there is only one bit. So if I start, so what will I check? So I'll check maximum value. So m always represents the maximum value. So initially it is 0, right? So first I'm checking is 0 less than 10. Yes. So that means I need to increase one bit. Okay. So I'm increasing one bit. So how I'm increasing? So now my m will become 1. So what is this 1 represents? That means up to now I can find value of maximum value as 1. Okay. So here I'll increment my count plus plus. Okay. This is one step. Next. Next time what happens? If I take 2 bits, what is the maximum number? What is the maximum number? My maximum number is 3. So next time I'll check. Is 3 is less than 10? Yes. That means I need to increase one more bit. So this time, yeah. So yeah, after this, I should add. Okay. So 3 is less than 10. I should increase one more bit, C++. Next time I'll increase one more bit. If I increase one more bit, 4 plus 3, 7. Is 7 is less than 10? Yes. So still increment count. Okay. So after then I'll increase one more bit. So if I increase one more bit, what happens? So 8 plus 4, 12, 13, 14, 15. Okay. So is 15 less than 10? No. Okay. Then I can stop. Then I can print. Okay. So if 15 is less than 10, that is maximum. If I take here count was 1, count was 2, count was 3. Okay. So here count becomes 4. So here the condition failed. Then I'll be printing count is equal to 4. Yes. Either you can do this process or simply we will do that right shift one only. So we'll just write down the logic and then we'll see another question. I hope everyone understood. Everyone understood this question, right? Don't get confused. What I am doing, so just do right shift operation, so that all those things while loop that becomes very big. Okay. So instead of that, we can go for easy number. Okay. So for example, if I take 10, so I'm just doing right shift. So it becomes 0, 1, 0, 1. Okay. Next, if I do one more time right shift, 0, 0, 1, 0. Next, if I do one more right shift, 0, 0, 0, 1. Next, if I do one more right shift, it becomes 0, 0, 0, 0. Yes. So after that, I'll be stopped. Total, how many times I did? I did 4 times. Yes. So fine. Instead of wasting time, okay. So we'll just do it. So I'll just write down that logic. I'll not write int main all those things. So I'll directly write down while loop. While of. Okay. So yeah. So next, let us take some n value. So here directly I'm taking n is equal to 10. So you write down scanf all those values. So when n is equal to 10, while of n. So directly I'm writing while of n, because if it is a non-zero value, then do it again. So whenever it is a 0 value, stop. Okay. So whenever value becomes 0, I'm stopping. So that's why I'm writing while of n. Okay. So every time I should increment it, right? Okay. So yeah, I'm doing n is equal to n right shift of 1. Okay. And every time you do increment count value, just 2 lines. So initially count is equal to 0. So initially count is equal to 0, take n is equal to 10 until your value becomes 0. Until your value becomes 0. Okay, do the right shift operation for one time, every time increment. Okay. So after this, print that count value. Question looks very big, but okay. Solution is very simple. I hope everyone understood. If you have a doubt, please ask. Okay. So this question is very easy. We'll see one tricky question. Okay, 1 minute. 1 minute. I'll try to find out that stair question. There is one important question called stair question. Okay. So I'll give you one question. 1 minute. Okay. I'm trying to find out where is that question. Give me 1 minute. I'm trying to find out. Yeah. Even this question looks very difficult, but it's actually very easy. Okay. So everyone, try this question. I hope you can see the screen. You might have came across this question. Yes, I can see them. You can see my screen, right, everyone? Yes or no? Yes, fine. Okay. So actually, next we have there was one more question, which is actually only calculations. There is no logic to discuss. Just you need to calculate, and then you should find bank one or bank two. When we have time, I'll discuss that question. But this question is somewhat tricky. Yes. Try this question. Any idea how to solve? There is a staircase with n steps. We can climb one or two steps at a time. Given n, write a function that returns the number of unique ways you can climb the staircase. Okay, so the order of steps matters. So give an example, when n is equal to 4, there are 5 unique ways. 1, yeah, all those things are there. What if instead of being able to climb one or two steps at a time, you could climb any number from a set of positive integers x. For example, x is equal to 1 comma 3 comma 5. Okay, so you could climb 1 comma 3 or 5 steps at a time to generalize your function to take x. Yeah, so they have explained us by taking 1 and 2, but they are asking what if you can climb any number of steps from a given set. Yes. Okay. So this is kind of important, only repeated so many times. Uh, yes. Uh, Understood the question, or should I explain? Yes, everyone. Are you there? Can you hear me? Yes. Okay. Uh, yeah. So any logics for this question? Any logics for this question? Anyone from CSC department, CSC, C, Triple E, Actually, I don't want coding. I just want the logic. What logic we'll be applying here? Yeah. Any answers? Any logics? No one? Okay. Shall we discuss? Yes or no? At least respond now. Okay, fine then. We'll start. Okay. Thank you, Shanti. Yeah. So first, understand this question. Actually, this question is very easy. So you have solved. So if I tell the logic, okay. So you itself, you have solved this type of program many times. Okay. So but you don't know that you'll be using that kind of a logic here. Okay. So I'm just taking some test cases. Okay. So first, let me work with this one and two. So first, understand the question. Okay. So then we'll come for this 1 3 5 all those things. Okay. So first, uh, let us take when n is equal to 1. Okay. So if there is only one step, yes, exactly, 427, that is what we'll be doing here. Okay. So you already know the logic, right? So try to write a program. So write a program and send me. Okay, I'll check whether it is correct or not. Okay. So let me discuss. Okay. So when n is equal to 1, that means there is only one step. Okay. So when n is equal to 1, so in how many ways I can climb this one step? So I'm writing step 1. Okay. So you can climb either by using 1 or 2. So when n is equal to 1, in how many ways we can climb those steps? Only one way. Okay. One way. When n is equal to 2, let me take, there are two steps. Okay. So either you can go by using one step and one step. Okay. Or directly you can climb two steps. So one and one or two. Yes. So here how many ways are there? Two ways. What are those? One and sorry, one comma one and two. Sorry, one comma one and two are those ways. When n is equal to three, how many ways? Okay. So let us try to find out. So by using single one step, one comma one comma one. Okay. Or I can go with one step and two steps. Or two comma one. Any other ways? Okay. Any other ways? No. When n is equal to three ways. Okay. So when n is equal to 4, they have already given. It's right. 1, 2, 3, 4, 5. So when n is equal to 4, 5 ways. If you already know the logic, then try to write a program. Write a program and send me. I'll check in the chat box. Okay. So when n is equal to 5. Okay. So when n is equal to 5, can anyone tell me how many ways will be there? Yes. You'll actually get 8 ways. Yeah. Okay. So when n is equal to 5, 8 ways. So if you observe all these numbers, if I write down all those numbers, all those ways, 1, comma 2, comma 3, comma 5, comma 8, and so on. So did you see any pattern here? Did you see, can you observe any pattern in these numbers? Yes. Anyone? Uh, can you see any pattern here? 1, 2, 3, 5, 8. Yes, exactly. So if you observe, what is the pattern here? Okay. So what is the pattern here? Sum of previous two numbers. Exactly. Okay. So what? So if you observe, 3 can be written by using 1 plus 2, 5, 2 plus 3, 8, 3 plus 5. Okay. So can I tell this is actually nothing but Fibonacci series? Yes or no? Yes, Fibonacci series. So yes, actually. So if you want 3 steps, you can get either by using 1 or 2. So if you want 5 steps, okay. So if there are sorry, 1, 2, 3, 4 steps. This is for 4 steps. You can climb by using 3 and 2. So in this 3 only, already 1 and 2 are already covered. Yes. So actually it is nothing but you should find out Fibonacci series of 1 and 2. Okay. So directly for this question, okay. So for this question, I can directly write f of n is equal to f of n minus 1 plus f of n minus 2. That is what Fibonacci series is. Yes, this is only for when one or two. So now tell me the condition. Tell me the condition for these question when x is equal to 1 or 3 or 5. So now tell me the condition, write down. So send me in the chat box. Okay. So what will be the condition when I can steps 1 or 3 or 5 steps? What will be the condition? Okay. So if there are only two things, I can write either one step or two steps. Okay. Why do I write f of n is equal to f of n minus 1 plus f of n minus 2? Because you can take either one step or two steps. Okay. So if there are 1, 3 and 5, then tell me what should be my condition. So for f of n, it should be either one step or three steps or five steps. Yes, f of n is equal to f of n minus 1 plus f of n minus 3 plus f of n minus 5. So either one step or three steps or five steps. Okay, so that is what actually this question. This is also about pairing question also. Okay, so for even friends pairing also will be of same type. Okay, two either two friends or three friends. Fine, we'll see that question later. Yeah, this is what the logic. Fibonacci series of n is equal to n minus 1, n minus 3, and n minus 5. Yes. So now write down the logic. Uh, Write the logic for this question. Yes. Okay. Okay. I'm launching a poll. Yes. Please give feedback. Okay. So after this question, we'll stop it. If you have any doubts, please ask. Okay. Yes. Everyone give feedback. Only 40% is done. Okay. You people try this code. So I've told you the logic is the Fibonacci series. Okay. So you can try it in home. No issue. So if you have given feedback, you can leave. So try it in home. Okay. So if you are not getting, we'll see tomorrow. Yes. So if you don't have any doubt, uh, if you don't have any doubt, give feedback and then you can leave. If you have any doubt, please stay and ask. Yes.